CSOs, rehab, and before and after rehab monitoring. He is a proponent of developing new guidelines to better improve sewer rehabilitation results. So here's Peter Keith speaking about Pierce County's battle with RDI&I.
Thank you very much, Sue. I was just struck in the last talk about getting 37 inches of rain in one day. And I was having a conversation just yesterday with our third speaker, Alton, and we said, when there's that much rain in a day and the water's coming into basement windows, you shouldn't be fined for any kind of problems you have in the collection system. So that's just my take on 37 inches of rain in a day. That never happens in Ohio. Okay. Title of my paper is Pierce County Wins a 35-Year Battle with I&I. Authors, myself, Robin Ordonez, next to the microphone here, is former Assistant Wastewater Manager for Pierce County, now with Predel Systems. And any questions that I can't answer, he will be able to answer. Kip Julie, Strategic Planning Asset Manager for Pierce County, did a lot of our GIS work, and Terry Soden, Maintenance and Operations Manager for Pierce County, took a look at the report we put together and made sure that it was up to their standards and et cetera. Shift doesn't work. That will work. Got to know this company in a webinar. I don't know if you folks go out and look at the WF webinars, but this is how I got introduced to what these folks do. September 2013, a WF LinkedIn webinar, a precast fiberglass reinforced plastic manhole liners. Well, what are they? It turns out the top picture on the right-hand side shows a manhole base liner, and it shows the tiebacks into which the concrete sinks when you flip it over, as shown on the bottom, and pour in the concrete, perhaps any rebar that you need in order to make it a full-size, high-strength concrete manhole base. And then when you flip it back over, what the sewer sees is the fiberglass reinforced plastic, which is impervious to corrosion, impervious to water, and it's actually pretty slippery, so it cuts down the amount of maintenance you need in each manhole. So first step is to get the molding. Second step is to get the thing encased in concrete. Second thing we learned is that it was invented to prevent corrosion initially. This picture shows, top right picture shows a badly corroded chimney, manhole chimney, atop a fiberglass reinforced plastic base liner. The base liner is intact. Constructed in 1994, so it's only been about 20 years since the sewer went in the ground and the top of the manhole is already corroded. Bottom picture shows a complex precast liner, watertight pipe connections. Those are all pressure fittings that allow some play in the pipe as well. The idea is to, when you put together a system like this, is to keep all the water out everywhere, including the angular spaces around the pipes. Fourth picture, completely lined, new golden fiberglass reinforced plastic manhole, including polypropylene steps that are protected, bench treads. You have great visibility, it's corrosion resistant, non-clogging, reduces maintenance. And when I drop my tools and I drop my tools a lot when I go in manholes, I don't know what it is about them. In these manholes, you can see the pliers at the bottom of the flow, and you can pick them up. You don't have to fish around for them so much. Rehab, the last picture, bottom right, shows rehab on an existing manhole where the concrete has been scarified, liner's been placed in the manhole, it's braced toward the outside, and have to pour concrete into the handler space behind the FRP liner. Characteristics of the liners, invented in Germany about 1975 to prevent corrosion. They're 3 millimeters thick. 2 millimeters have been tried a couple of times. They had a couple of cracks and failures, went to 3, and it's been fine since then for the most part. We'll get into that. The resins can be changed for special industrial applications. Typically, there's a polypropylene liner used for wastewater applications. They can, at 50 to 100-year service life based in corrosive sewers, corrosive wastewater, based on typical sanitary. The service life is based on destructive testing that's been done on polypropylene over the years. Molded to any size or shape, all penetrations are lined all the way to the outside of the concrete to completely protect the concrete from corrosion. They happen to be brighter and more slippery than reinforced concrete manholes. That's a little bit of that's a side benefit. They also happen to be watertight, which has been my business for the last 38 years, and that was interesting to me. Sort of hit the rare trifecta of performance. They prevent corrosion, they minimize O&M, and they also eliminate I&I. I was intrigued. So I asked my acid question that I always ask: do you have any before and after rainfall and flow data? Before and after data are the gold standard to tell whether or not your I&I was actually reduced or not. Your before data can be taken in a wet season, your after data can be taken in a dry season, and even though you didn't move 1 gallon of I&I, it'll look like it had a 50% reduction because the rainfall wasn't accounted for. So, the search for data is centered on Pierce County, Washington. Pierce County stretches from Puget Sound in the city of Tacoma out to Mount Rainier in the Cascades to the east. The county had the largest installed system of fiberglass reinforced plastic manholes with 11,000 baseliners installed. Of the 11,000 baseliners, 6 have failed over the years, cracked. That's a 99.95% intact installation. All 6 can be repaired in the field. 4 of the 6 were cracked because unauthorized people cored through the manhole and cracked the FRP plastic on their way in with the core. We'd like to train folks to core properly so that that doesn't happen. In this case, 6 out of 11,000 manholes got past somebody. Originally specified in 1989, to reduce O&M, it turns out that Pierce County had many, many corroded reinforced concrete manhole channels that had to be broken out and rechanneled because they were causing lots of debris clogging. Robin Ordonez, sitting over next to the microphone there, said there's got to be something else. Some guy walked in with these polypropylene liners and he said, why don't we try those? They tried those in 1989. They've been specified by brand ever since because they worked. Pierce County collection system performance is quite exceptional. I've done this over 100 times and I've never seen one like this. It's a young sewer system, a big advantage in being young. Starting in the 1970s, very quickly after the new guys got in, they said, we want to get rid of the PVC, not the PVC, they want to get rid of the reinforced concrete and vitrified clay pipe that was in the system. Today, 95% of the system is PVC or HDPE pipe, including the laterals, which are mostly PVC. It's not a small system. It's 800 miles total, 700 miles of public main line, 130 of private main line. That means maintained by somebody else other than Pierce County in this case. There's 100 pump stations and 800 grinder pumps specifically around lakes. This system has never had a capacity-related SSO. The system had never had an NPDES violation of any kind. The peaking factor at the treatment plant during a 10-year storm was 2.2 to 1. That's Qmax over average daily flow. O&M costs also happen to be the second lowest in the region. In 100 sewer systems that I've evaluated, I've never seen anything quite like that. The typical peaking factors that I see are 8 to 1, 12 to 1, 30 to 1, stuff like that during heavy rainstorms. So the first thing I said, boy, this story deserves a podium. We need to know how people did it right. And the second thing I said, can we find any support data to actually tell what happened? Well, it turns out Pierce County did have a lot of data. We found flow data from 16 flow meters, and they gave us data for the entire year of 2011. Found data from 7 rain gauges. 6 of them were from Pierce County, 1 from NOAA. And what we got here is a picture on the bottom right-hand side of a rain gauge. Center in the bottom is a tipping bucket. I know a lot of you folks know how a tipping bucket rain gauge measures. It's down to the hundredths of an inch. And the data was 5-minute data, which is very good. And the flow monitoring data were also 5-minute data. So we had something to really sink our teeth into and do some evaluation. We cranked the GIS and flow data, rainfall data through some really fast RDII engines. GIS, rain, flow, all dumped into an online program called Slicer. We're able to do scattergraph evaluations to tell whether or not there are any blockages in the sewers right out of the raw flow data, capacity evaluations to see whether or not they could pass 2-year, 5-year, 10-year, 100-year storms using all the flow data plus the output from Slicer. Calculations and graphics were all dumped into a master template, and then the master template was merged to a template flow report. And this whole thing took only 80 hours to process. Did 23 site years of data, 288 basin storms, and wrote the 133-page report. Database and template to do this are available. See me afterwards if you want to talk about it. Kip Julian from Pierce County processed all the GIS data, and that was not trivial. I'm going to go through an RDI analysis in a minute here if we can. First thing we got from the data is a relationship between the upstream and the downstream meters shown here in the schematic. Second thing we did is we did sensible sanitary sewer basins. The concept in the sensible sanitary sewer basin is to eliminate non-sewered areas from your evaluation. Eliminate the parks that don't have any sanitary sewers, eliminate the cemeteries, and pretty much draw your basins around the backside of all the houses. Any place where you think, in your experience as an engineer, you're likely to have connected to the sanitary sewers, what this is all about. Srini Balabanini, one of the guys from the collection systems here at WEF, came up with this concept in the SSOAP toolbox. I think it's a great idea, and one of the big advantages of this, two great advantages, is one, you can use this data to predict rehabilitation success, and I think our next author is going to talk about that. Two is you compare System A with System B with System C in all parts of the country and all over the world. Three, the third thing we did is had rainfall hydrographs, one for each rain gauge. We had geographic rainfall distribution. The math for this came from Claudius Ptolemy in a book stored at the Library at Alexandria in Egypt in 430 AD. I want you to know we're bringing you the most up-to-date information we can. Fifth thing that we did was depth, duration, frequency graphs on every single storm. We were able to tell you whether or not it was a 2-month, 3-month, 4, 6, 9-month, 1-year, 2-year, 5-year, up to 100-year storm. You need to know what kind of storm drove your problems. Otherwise, it's like driving a car without a tachometer. You never know how fast the engine is going. 6, we did scattergraph evaluations at every site to see whether or not there are hydraulic problems out there. At hydrographs from every site, the blue line up here shows the flow in the sewer. The purple bar graph shows the rain, and the light green over on the right side of the graph shows the dry days and the wet days that were selected to create the dry day curves that modelers love. Here's the dry day generation. We generated 32 of them, weekend and weekday for all 16 sites. And then we took the dry day data and subtracted it from the wet day data to get the peak RDII rate, which is that gold line in the middle. And so we needed to get peak rates and total volumes. And in order to do that calculation really fast, this all happens inside Slice. We have 5 periods: a pre-condensation period down on the x-axis, a storm period, recovery period 1, recovery period 2. Those recovery periods are where you're going to see most of the infiltration. You think you're going to see most of the inflow during the RDII, but I always say that inflow and infiltration are largely mixed, and you can't tell until you do your SSES work which is really which. Sometimes 90% of your inflow is really infiltration. The last thing we did was flow projections, which is what you need to do to get out to the capacity evaluations of the site. Results from the RDI evaluation showed that Pierce County really did have very little RDII. Excessive RDII shown on the top line would have been shown in red on this chart, with more than 10% rainfall ingress getting into the sewers. There was none. Over 5% RDII, possibly excessive RDII. There was none of that in none of the basins. I've never seen one like this. Every single site could pass a 10-year storm without overflowing. Many of them could pass a 100-year storm without overflowing. No relief sewers were needed for SSO reduction, and therefore there was little or no economic incentive to proceed with any SSES work, smoke testing, CCTV, and etc. All basins, all 16 basins, were non-excessive for RDII with less than 5%. The top right basin, PCO1 at 4.5%, the one below that 3%, down to the bottom where we had basins that showed no RDII at all. Comprehensive Rehab Production Tool, we'll tell you about that, shows that likely RDII removals from comprehensive rehab in any of these basins is equal to 0 you could go out there and line everything and get 0 gallons out. Learn more in the next paper. Decision matrix included maximum percent rainfall results. We've just gone through them. We also took a look at base infiltration because that's what the regulators always wanted to see. And according to EPA guidelines, PC19 shows up as having excessive RDII because there was 3,760 gallons per day per inch mile, and EPA drew a line in the sand at 3,000. So, is it really excessive? Well, with the rehab unlikely to eliminate any measurable RDII in that system, and the measurable RDII shown at 0, what do you think? That's like an already transported 10-year storm, so there's no economic incentive to do anything there. And that points out one of the problems of just following a metric, the EPA metric for 3,000 gallons per day per inch mile. You don't even have to measure it on a wet day. There's no mention of rainfall in it, and we need to have new metrics. Relative costs in leaky sewer, unlike Pierce County, look like usually have about 50% of the present work needed to upgrade the system in relief sewers. And in this case, this system, $30 million of relief sewers were needed if no rehab were done. Total cost for doing everything in the system, including sewer lateral rehab, pump stations, wastewater treatment plant improvements, would have been about $60 million. So relief sewers tend to be, in most cases in a leaky system, your largest driver for whether or not you're going to go ahead and do rehab and SSES work. Since Pierce County needed no relief sewers, the incentive was not there. Now here we're able to compare Pierce County to the results in other sewer systems, and this is one of the advantages of the metric we used. What we found was Pierce County had 71% maximum RDII than the next tightest sewer system that I've ever seen. And that is an anomaly of the very first magnitude. I've never, ever seen anything this tight. If you want to know how to do things right, you should talk to the Pierce County folks. I had data from Westlake, Ohio, Shelton, Connecticut, Copley, Whitehall, Pennsylvania, all very well-run sewer systems. And the Pierce County data was 70% drier than the next best one, and 80 and 100, 150% drier than some of the others. So I encourage you to take a look at the Pierce County specs. You're going to have the URL on several of the following slides. So here's the question. Is it possible that the golden manholes were responsible for the historic low INI? That's the question that we needed to answer. In order to do this, we had to figure out, well, how much of the system is really affected by those manholes. So we invented a new metric for manholes, vertical inch miles, as opposed to the inch miles that you usually see in a collection system. 1 mile of 8-inch diameter pipe is a footprint of 8 inch miles. 2 miles of 8-inch pipe is a footprint of 16 miles. Here's a factoid. It's an area. An inch mile equals 440 square feet. Or if you're Canadian or European, 1 centimeter kilometer equals 10 square meters. 48-inch pipe comprises about 0.1 vertical inch miles. So it works out that 10 to 20% of each basin in Pierce County was comprised of manholes. Even less, perhaps 3% of the system has been lined with those baseliners. With all else being equal, the manholes should contribute only 10 to 20% of the INI, but all else is not necessarily equal. If all sewers are tight, all the remaining leaks could be in the manholes, but every manhole also has a 24-inch diameter opening at the top that could ship, under the right conditions, can ship millions of gallons a day into the sewers. 15% of the system was manholes, 71% lower RDII. We're figuring there were some other factors in play, and there were. Just what has been Pierce County's recipe for success. But didn't start out to build the tightest sewer system, just the best. First sewers went in the late 70s. We've talked about ditching the brittle VCP and RCP pipes. That helped a ton. They're continuously improving their engineering design standards. Inspection and testing include vacuum and hydrostatic testing and CCTV inspection. They require a 1-year warranty on all new construction with testing at the end, and the contractor doesn't get paid the retainer till the end. There's a thorough preventive maintenance program, and there's a green light to sole source the best of the best if needed. One result of this sort of program is that they have very low monthly sewer rates. Building the best sewer system showed Pierce County ends up with the second lowest sewer rates in the general area. So excellence apparently pays off. High quality has been a product of a government that has worked very well. All 6 sections got together. They get together in bi-weekly meetings every week. They have been cultivating a culture of cooperation, and that has avoided fiefdoms that we see in a lot of other municipalities. All staff impacted by capital projects are included in design review and construct